In this example, I want to do an analysis on this hook, and we're going to apply 100 tons of force on the hook. And to give you an idea of the size of the hook, so we have a bunch of pulleys down here, but over here is a large pickup truck, and so that gives you a sense of scale of the size of this hook. It's a pretty big size hook. Now notice that there is a latch that goes over here and a latch that goes over here. We're going to analyze this without the latches to assume a worst case condition, and we're also going to assume that there is a pin placed into the center of the hole. And so first I'm going to change that color to a gray color. Since red is one of the colors in our analysis, we don't want that to overwhelm what we're seeing in the analysis. Then I want to apply that force over here, and I want to apply it over here, and I may want to represent a strap or a chain coming across here, chain coming across here, and I might want that at an angle. Now I'm going to start a new sketch on the front or XY plane, and then I'm going to project geometry the arc that's in the center here, and so I'll project that, and I'll project that, and go ahead and project that, and I was hoping to get a center point here, and so I'm going to undo those projections and see if I have an earlier sketch that I used to create the geometry. I'm going to turn on the visibility of the sketch, some of the geometry that was used to make this, and then I'm going to project this point right here at the intersection of these lines at the center of this arc, and I'll go back and then hide sketch number 2, and I will do a 2-point rectangle out here in space someplace. And I want to put the midpoint of this line at this projected point, and then I will dimension the height of this some distance, let's say 7.5 inches, and I'll dimension the width of it as 5 inches. Now let's say that the strap that I put on here, or the chain, I want it to be in this area, ideally right in here, but let's say that I'm going to put it in at an angle. So I'm going to put this line in, say from here to here, so I want the load to be along that line. So I'm going to change that to construction. We'll use that later. And then I'm going to put another construction line in over here, and I'm going to change that to a center line and a construction line. I'm going to mirror this geometry on the other side of this line. So I'll do a mirror, and I'll select this geometry over here, and I'll select the mirror line. I'll say apply to that, and done. And just to tie this all up, I'm going to constrain the end of that line to this line. Alright, then I'm going to split this face. Now I have several faces here, so I have a face here, here, here. I'm going to split several faces to apply my load. And so I will finish the sketch, and I'll do split. I'm going to select this rectangle, and I will tell it to split everything that it encounters. So I'll say split all, and I'll select the part, say OK to that. So it split those faces into more faces. I'll make that sketch visible again. So I'll turn on the visibility of that sketch, and I'm going to split the other side. So I'll do split again, tell it to split everything that it encounters. I'll select the part, say OK to that, and now I'll hide that sketch. Alright, then I'm going to delete these individual faces. So I'll do delete face, and I'm going to delete each one of these individual faces. And before I do that, at the top of the browser, notice that I have one solid body. And so I'm going to delete those faces, and before I had 2 surface bodies, now I have 3 surface bodies. And so our part is now a surface body rather than a solid body. I'm going to replace those individual faces with a single face. So I'll do boundary patch. I'm going to select this, and I want this boundary patch to be tangent to all the edges that we split. So I'll select tangent, and I'll say apply on that side, and then I'll do a boundary patch on this side. Again, I'll put it tangent. Then I'll stitch this back into a solid. So I'll do stitch. I'll select these 2 boundary patches in the original body. We'll stitch that all back into a solid. Alright, so now I end up with those individual faces replaced with one face for each location of the load. When I go into the analysis, I really don't need these holes and these features in the analysis, as that just takes it longer to mesh the part. And we'll go ahead and set up our analysis. So I'll go to environments, I'll select stress analysis, we're going to do a static analysis, and I'm going to go ahead and do a fixed constraint on this face. But actually, before I do that, let's get rid of the extraneous geometry. So I'm going to expand this, and I'll go and find these features that I don't need. And so I see that this extrusion, I don't need that extrusion, so I'll exclude that from the study. Now, because these fillets and the mirror of that feature to the other side were children of this parent extrusion, it automatically took those features out as well. And let's see if I can get rid of some of these extra chamfers in here as well. So there's a chamfer up here, I'll exclude that from the study. We don't need for that to be meshed. And there's also one down here. If I can find that, we will exclude that chamfer from the study. So we idealize the model to make it easy to mesh and remove some of these smaller features that we're not concerned with. When you're working on a part of this complexity, make sure that you save often. I then want to turn on the visibility of the sketch that I used earlier to put these faces. So I'll go back and find that sketch, and I'll turn the visibility on, because I want to use this line right here and this line right here to define the direction of the force. Now I'll go back to my study, and I will then put in the force, and I want to put it on this face, but I want it to follow along that direction. So I'm going to select the selection tool for defining direction. So I'm going to have it go along that direction, and I'll put 100,000 on this face, and then I'll select this face, and I'll select the direction. I'll select that line to define the direction, 100,000 on this face. Then I'll go back and I'll hide that sketch. I don't need to see it anymore. So I'll turn off the visibility of that sketch, go back to my study, and so I have 100,000 pounds on this side, 100,000 pounds on this side. I'm going to put a fixed constraint on this face, and then I'm going to do a pin constraint on this hole. And let's expand this dialog box. So the axial direction is along this axis, along the z-axis here, back and forth like this. We know that that's fixed. For the radial direction, the hole going out radially all the way around, getting bigger and smaller. But I'm going to leave the tangential direction unfixed, so that if there was a pin in here, as this pushes down here, it can rotate around here, it can rotate around here tangentially around that pin. Then I'm going to mesh the part, and I might want to increase the density of that mesh some. So I'll go to my mesh settings, and let's do this as, I'm going to change that to 0.05. I'll change this one to 0.05. And for the maximum turn angle, let's say 30 degrees on that curve elements, and we'll update our mesh. I will then check my material. So let's select the assignment of the material, and I see that the material hasn't been defined, and so let's make this, let's say, alloy steel. So I'll select steel alloy, and then we'll run our simulation. After running the analysis, we can animate the results to see how the stress is rising in the part. We could also look at the displacement, and of course we see the maximum displacement, and that is an exaggeration. Keep in mind that the actual displacement is so small that we can't really see it. And then we could also look at the stress in the y direction, and so we see that these areas are in tension, and then where the connecting straps or chains would go across the hook, those areas are in compression. I've opened up the file as a step file in Fusion 360 and started a new study, and I'm going to go to the simplify tools, and I will remove some faces. Now I will remove this hole, this face, whoops, and the fillet on that side, and also the fillets on this side in extrusion. And I'll say delete those features, and then I'll do the same thing on the other side. And so I'll delete the whole, this face, the fillets on both sides, and then for some reason it had trouble removing this face, so I'll just do it again. And then I want to remove the chamfer. So we idealize the part for the purpose of analysis, and I'll remove the chamfer over on this side. And I have one more chamfer that I want to remove up here at the top so that Fusion doesn't have to mesh those features. Alright, so I've simplified the part, and then I want to put in some geometry to allow me to set the direction of the load. So I'm going to do a new sketch. So let's go back to simplify again, and I'll do a new sketch on this plane, and I'll do P for project, and I'm going to project this point and this point. So I've projected that geometry, and I'll also project the corner over here and the corner over here. Alright, then I'm going to draw a rectangle, and I'll put this rectangle about like that, and then I'm going to drag this corner of the rectangle over to here. I'll do the same thing on the other side. I'll do a rectangle, and I'll put this rectangle over to here. I'll make these two lines collinear. This one collinear with this one. Our original dimensions, it was 5 inches on this side or 7 inches, I don't remember. I'll go ahead and put in 7 inches, and that looks like that goes to the center. And let's change these units while we're here. Let's change those to inch units. Alright, and then to set our direction for the load, we went from the midpoint here and over to here, and then we went from the midpoint over here over to here. Alright, so those just give us some vectors on how to apply the load. I will finish simplify, and when I did that, the sketch is no longer visible. Since the sketch is no longer visible, let's try doing this an alternate way. So I'll go back to simplify again, and I will go to axis through 2 points, and I'll select this point and this point, and I'll do the same thing on the other side. So I'll do axis through 2 points, and I'll select this one and this one. And I'm hoping when I finish simplify that those axes will remain visible, which they do, so we can use those to set the direction. Alternatively, what we could do is calculate the components of the forces, but I'd rather not do that if we don't have to. Alright, we'll do a fixed constraint on this face, and then I'll do a pin constraint on this cylinder. And so I'm going to constrain it radially. I'll constrain it axially, but I'll leave tangent free. Now you may want to experiment with this different ways. Perhaps remove the axial constraint. So do a clone of this study and check it with different options of constraints. I will apply my material, and so let's go to the materials, and I'm going to pick steel alloy. And I will apply my load. So I'm going to do a force load on this face, and I want to follow that direction. And I try to select as a reference this axis or this axis, and it doesn't allow me to select that as an axis. So let's cancel out of this, and I will go back to simplify, and I will find the sketch. And I'm going to dimension the angle between here and here. That will be a driven dimension, so I'm going to put in 19.7 as my angle. So I'll finish. I'm going to attempt to apply this load again, and I will select the face where I want the load, but notice the coordinate system is not lined up with my origin planes. So I'll select reference and try to select the origin planes, but it doesn't allow me to select the origin plane. So I'm going to select this face up here, and now notice that this is lined up with that face, perpendicular to that face, and I will drag this to minus 19.7. Now we probably should just round that off to 20 degrees. If we're loading this hook with straps or chains, we're not going to be able to load it within 0.3 degrees anyhow. But just so that it matches our previous problem, I'm going to go ahead and put that in at a precise angle. And then I'll do 100,000 pounds force. I'll do the same thing on the other side. So I'll do the load on the other side, and again I will select as reference the top of the part to line up the coordinate system. And then I'm going to start to line this up by eye, and I'll put in the 19.7 on this side and 100,000 pounds force. All right, we defined our material, we defined our load, we defined the constraints. Let's go ahead and mesh the part. I could refine that mesh if I chose. We'll go ahead and run it the way it is, and so I'll go to solve. I'm going to solve this locally. You see our safety factor. I will display the stress, and I want to display the stress in KSI. So our high stress is in this area right in here with the angles that we have for the load, and then for the displacement we see our displacement about 2.5 thousandths. If we go back to the stress and I want to show the high stress area, I'll drag this slider up in here so we can see that right in this with these at an angle, here's the location of the stress. We should run this again with the load going straight down. In this example, I brought the part over into SolidWorks